Triangle congruence by side, 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 and side angle side. Our objectives are to apply side, 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 and side angle side to solve problems, as well as prove triangles congruent by using side, 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 and side angle side. Who uses this? Engineers used the property of triangle rigidity to design the internal support for the Statue of Liberty and to build bridges, towers, and other structures. Let's look at the postulate for side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. In the previous lesson, you had to find all three sides and all three corresponding angles. Now we're shortening that up. If you're dealing with triangles, as long as all three corresponding sides are congruent, then your triangles are congruent. Let's use side, side, side to explain why triangle PQR is congruent to triangle PSR. So we need to make sure we have all three sides. So they gave us that side PQ is congruent to side PS. They also gave us that side QR is congruent to side SR. But we need one more side. Well, the side PR. PR is going to be congruent to PR. So PR is going to be congruent to PR. And that is by the reflexive property. For this next piece, we're going to need to know what an included angle is. An included angle is an angle formed by two adjacent sides of a polygon. So angle B is the included angle between AB and BC. It's the angle that's smushed between those two sides. Alright, so let's look at side angle side. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Now, this angle here is the one that's smushed between the two congruent sides here. So AB is congruent to EF, AC is congruent to ED, and the angle is smushed between those two sides. It's not sitting off to the side somewhere, it's in between those two sides. Let's look at an engineering application. The figure shows part of the support structure of the Statue of Liberty. Use side angle side to explain why triangle KPN must be congruent to triangle LPM. Well, they gave us that KP and LP are congruent to each other, and NP and MP are congruent to each other. So we just need a set of angles that are smushed between those two sides. So it's KPN and MPL. Well, we know that they're going to be congruent because they're vertical angles. So therefore, side angle side does in fact work. Let's practice verifying triangle congruence. Show that the triangles are congruent for the given value of the variable. So if x equals 3, show that these two triangles are congruent. You're not proving anything, you're just showing. So therefore, showing your work is substantial enough. So if x equals 3, we know that xz must be 3. And if we plug 3 in here, we have 3 minus 1, which gives us 2. And then we have 3 times 3 minus 5, which would be 4. So our corresponding sides are, in fact, congruent. Let's try one that's a little bit more difficult. Y equals 7. So we want to plug in our value of 7. So we have y, so we have 2 times 7 plus 1 is going to give you 15. And then we have 12 times 7 plus 42, which is going to give you 126. And then you have 7 squared minus 4 times 7, so 49 minus 28 plus 3 is going to give you 24. So we have a set of sides, the included angle, and then the set of sides. So this one is, these two triangles are congruent by side angle side. Let's look at a proof. JK is congruent to ML, and angle JKL is congruent to angle MLK. Now we need to prove that our two triangles are congruent. So we have JK is congruent to ML, and that is given to us. The other given that's not in this first statement is angle JKL is congruent to angle MLK. Once again, you always start with your given and end with what you're trying to prove. Alright, so we've got ourselves a set of angles and a set of sides. But we need one more piece of information. You still need at least a minimum of 3 pieces of information, even though we are shortcutting it, which is still half of the information. So we have KL. They both triangles share this side. So since both triangles share that side doesn't suddenly change size. So therefore, by the reflexive property, we can state that KL is congruent to LK. And then we have ourselves a side, an angle, and then a side angle, and a side. The angle is smushed between those two sides, so it is side, angle, side. Let's look at another proof. Alright, so we need our statements, and we need our reasons. This one's a little bit more difficult, only for the sheer fact that you don't have any helpful hints as you kind of go through this. But I believe in you. I think you can do it. So let's start with our given. We have L is parallel to M, and they were oh so nice to give that to us. Now, since they are parallel, we can use that these two lines are parallel to help us find some angle measures. For example, we can use angle EGF is congruent to angle HFG. So EGF, so you can see it, is congruent to angle HFG. So you can utilize the alternate interior angles theorem. When you see that lines are parallel and you're trying to work with triangles, chances are you should definitely look for the alternate interior angles theorem, corresponding angles. Those things like to come up a lot in these proofs. Alright, well, we've got ourselves a set of angles here. And now let's go with our other given. We have EG is congruent to HF. And we have our reason being that they gave it to us. How nice of them. And we need one more piece here. So we have one side, one angle, but you need at least 3 pieces of information in terms of a side or an angle that are congruent to each other. So we can utilize that GF will be congruent to GF. So we have GF is congruent to GF, and that would be through the reflexive property. Oops. Sorry, crossed the long letter there. REFL, reflexive property, because that side length is just going to stay the same side length, and both triangles share it. And finally, we can end our proof. So we have triangle EGF is congruent to triangle HFG, and we utilized this side here, this side here, and an included angle, so therefore we utilize side, angle, side. And that ends our lesson on triangle congruence using side, 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 and side, angle, side as some shortcuts.